And the first one is Claudio Vitalini, CEO of EET BOZEN, a hydrogen center. Welcome. Choose wherever you want to sit. Then the second one is Kai Koenig from ABB Mobility. He's a program manager of public-funded R&D projects. The third one is Kathryn Wunderle from Air Products. She's a business developer for hydrogen for mobility. And then the last one is Mario Campo from Hitachi Energy. He's innovation and solution manager. Yeah, so welcome. You can see the slide that I have prepared. It's with a lot of numbers. The numbers are from the European Automobile Manufacturer Association, and they state that to get 30% CO2 target reduction, which they want to increase to 45% of reduction, we would need around 2080,000 zero-emission vehicles, and to charge or to fuel them, we will need more than 34,000 charging points, of which about 20,000 megawatt chargers, and we should also need around 2,000 hydrogen refueling stations in Europe, divided into 6 tons per day or 2 tons per day. Let's say that's what we need by 2030, following these numbers, following this source. Do you believe it will be feasible? I don't know who wants to start. Nobody? So maybe Claudio, can you say something about the hydrogen?
Yes. Yes, I wouldn't be here if I wasn't believing it. Feasible, of course, it is. We need a lot of investments, a lot of competence. I think here is the place where competences are exchanged. So it is a huge challenge for all the countries in Europe. Yes, it is in principle feasible as far as hydrogen is regarded as my sector. It means that you have to invest a lot in production and in fueling station, as well as in taking energy or electrical energy to the production points. So also the electricity network, distribution network is challenged.
Yeah. Okay. Kathryn, maybe you want to add something about hydrogen?
Sure, staying with hydrogen, definitely. Yeah, our products have been producing hydrogen for many, many years now, so 60 years. Of course, most of it grey hydrogen. So there's plenty of hydrogen out there. We just need to shift it from grey to green. That's the challenge. And as you said, figuring out where the energy is. So with our products, we're splitting our production between mainland Europe, but also places where there's more energy. Now the solar during the day or the wind at the night. So in the Middle East are some of the import projects. Yep. And so I'm not worried about producing the hydrogen. Yeah, we've got some mega projects underway that we've announced globally. Producing in NEOM, the NEOM Saudi Arabia project is 650 tons a day. So if we look at that the bottom number there, we need 6 times of those, fine. But we see every day different announcements. So the companies are ready and willing to invest in the hydrogen infrastructure. I'm also, as I say, not worried about the hydrogen infrastructure. The technology is there. We've been doing hydrogen fueling for 15, 20 years. So it's not a new technology. We've just got to increase the speed of it. Get to the 700 bar and increase the speed to get it into the bigger tanks for the trucks. But they're incremental changes. We're not talking about big technology changes, maybe like on the e-charging side. I do think the technology is there. We know how to make hydrogen. We know how to handle it. We know how to distribute it. What I love about these kind of projects is bringing the actors together. What we've got to figure out is where to put them. Who are the first movers? Who are prepared to drive the trucks that we're making, and decide where to put that infrastructure to get it in the right place for this project in 2 years' time. Yeah, because this is really the first movers. I'm not worried that by 2030 that'll be there, but for this project, we've got to get it there in 2 years' time. Yeah, for the beginning of the demonstration phase. And that's the exciting part, bringing the actors together at the right time, in the right sequence to get the technology there at the right time.
Yeah, so I hear that the hydrogen will be there. We import it if necessary, and also that I think Ben called it a technical gas. We know how it works, so that the hydrogen refueling station technology will also be present. Then we can go now to the chargers. Maybe you, Marco, what do you want to add?
My name is Mario, but
Mario, sorry.
Don't worry. Many use Marco. It's possible if we want this really happen. Then from a technical point of view is possible, but we need to be very organized from a let's say supply chain point of view, and we need to be very organized from the localization point of view, because this needs to happen in Europe, and with I think it's possible with European technology, because you will need to have the service of those chargers. And from a technical point of view, I think it's possible. From the investment point of view, I think it's possible as well. But I think it's more about the business case. It's about if the trucks OEM and the logistics company sees the business case, this will happen. 25 years ago, I was working in renewables, and we had exactly the same discussion that we have today. And to be honest, not many of us saw that it was possible 25 years ago, but it was what is possible, and we see it today. And I think here in this industry, we will see the same. We will see that those figures will happen, and we will manage only if there is a business case. And then the business case is something that we need to work together. The collaboration is super important. And that's something that we have already said here today many times, but it's super important.
And Kai, do you have something to add?
In principle, the step towards megawatt charging is the next step, like what we've done for buses up to 350 kilowatt. Before for cars, of course, the scale is bigger. There is more trucks than buses. We now go to a megawatt and more for the American market, especially a lot more. So I believe it's possible. I also want to add that end of 23, we also expect to get the first mega chargers along with Scania on the road, as was in the joint press release, and then the numbers will increase. But already with 350 kilowatt, and a lot of use cases can be covered. For example, we have seen now a food distribution center in a Nordic country that has added a large number of chargers and trucks, a significant percentage of their fleet today and running. There will be a lot of challenges also with the energy. We also need to make the batteries flexible as with when the charging exactly happens. There will be needs to invest not only in grid hardware, but also in software to make things intelligent, to reduce hardware costs by deploying software-based intelligence. And also we will be working on that. And with all that taken together, I think that is addressable. And it will probably be quicker than we think.
Yeah, so again, I hear that the charging technology will also be ready, and that when the first trucks, we heard that in 2024, the first commercial trucks will be available, then also the infrastructure will be available, but we need to start now if we want to have them installed in 2 years. Okay, I have a question about, where are you going to install it? I think it's also very relevant. The location is also related to like the business case and the energy connection. We also already heard a discussion on like night charging or depot charging or charging on the highway. What is your view on it, looking from the infrastructure side? Maybe Mario? Yeah.
Well, we need help from the users. They know very well the roads, and they know very well the locations. Once this is clear, we need to get the step to work on the grid connection or the localization in that area of the charger. The challenge that I see there is for mega charger system is the grid integration, because we are working with power, and power is affecting the frequency in medium voltage lines or networks and they are sensitive. Then the feasibility studies of the connection points are very important. And this is something that is not discussed in these kind of forums, but I think we need to start doing that, doing these feasibility studies of the megawatt charging locations. It's fully possible, huh? Technically it's fully possible, but we need to start discussing of that, because from a power electronic point of view, the charger point of view, we can do magic. You give us electricity and power electronics, and we can do anything. We can do even, let's say, active front ends. Then I can, at the same time that I'm loading a truck, I can balance the grid. But at the end of the day, the business case needs to be there. And the connection point is very important to optimize how I will use the power electronic and how I will use the power of the dynamics of the power electronics and the flexibility of power electronics to do one thing or the other, or both at the same time. Then feasibility of the grid connection, very important.
Yeah, because I heard today some numbers like 100 chargers or 50 chargers at one place. So I did a little calculations, but that is like connections of 15 megawatts or more, and that are like all big industrial plants concentrated at some chargers. So I don't know, Kai, do you have some?
We need to manage concurrency. We need to make sure that we flatten the peaks of the loading curves. This is, of course, especially well possible in overnight or when there's time to charge. That would be, for example, use cases like buses, use cases like grocery distribution, use cases where there's no overnight driving. There, a proper balance has to be found between maybe not charging each truck with 60 kilowatt and having no time to shift loads, but maybe staying with the 300 kilowatt range even for the overnight charging, and leave out areas when other consumers consume a lot of power. Maybe even to own heat pumps for heat generation, own industrial processes could be shifted. Hydrogen generation, if your electrolyzers can handle it and you want to take the invest, can shift onto low demand side times. We can, of course, schedule the charging of vehicles in such a way that the one that leaves next is charged first, that the charging during a bad time is only done so far as it's needed for the next route, when then at the next stop there's more time, better energy prices and energy availability. Again, here we can add intelligence, and if it's possible to do that through the pricing, we can also increase the business case for this. Local generation can help. As we heard, depot charging should be 70%, and we agree. In some cases, this might be 300 kilowatt charging. Some companies with very high running times of trucks might also want mega charging at their depots. If they want to have truck running 20 hours per day, that might be the better option. Some people might want to do the charging at the customer's loading ramps and negotiate with regular recurring customers. I mean, if there's 20 trucks coming to the same customer per day, one might consider doing charging there. Maybe to come back, where do we put the infrastructure? We, as infrastructure providers, of course, put them where our customers want it. Charging point operators for trucks will hopefully come, especially on the rest station, but it will also mean that some logistics company will be their own charge point operators and to operate the infrastructure on their depot themselves. We are very willing to help with that. We are very, very willing also to provide and co-develop with you some of the software I just mentioned. And also that will of course mean that you don't need to share the costs with others and make the business case feasible in a more early way. But kind of similar to like many companies already offer charging to their employees' cars. Sometimes with solar, they install themselves over the parking lots, just on a way, way bigger scale. And with more time needed to prepare, because upgrading your grid connection, buying the transformer, or even laying new cables if you need it, will take time, but it's a one-time cost. The transformer will still be good after 20 years.
Yeah, that's a good thing of that technology. So I understand that there will be a lot of charging at depots, so that a client probably has solar panels on the roof and directly use that energy to put it in their vehicles, in their trucks. Now I have a question for the hydrogen. So like the charging will be very close to the depots, and like the hydrogen refueling stations, are you now seeing also that logistic parties are asking to install it nearby their sites, or is it more focused on the TEN-T network? I don't know, maybe Kathryn?
Yep, sure. So I think we're expecting this really to evolve, and we think that the infrastructure will be completely different in 10 years' time to now. So what we hear is that the logistics companies, they really would love to do it on their depots. You know, the first movers would say, it's great, I've got my first 2 trucks, but I have to drive 30 kilometers to the next station. We don't want to do that. But likewise, they don't want the infrastructure, they can't put an infrastructure of 6,000 kilos a day on their depot today if they're already having a demand of 30 kilos a day. So we think when we get, is it not working? No. So we think that, you know, when the fleets ramp up, when the individual companies have bigger fleets, they really want to have the infrastructure on their depots. So that there'll be a lot more, you know, fueling infrastructure there. Right now, there was a great word earlier, mutualization. Yeah, right now we need to do bundling. We need to, for the business case, we need to put the fuel stations where the company who's being the first mover with 1 or 2 trucks, they can fuel. So that's going to have to be where people are driving. It's going to have to be on the motorways, and that's what you know, it's really going to encourage the market to ramp up. So that's where we're putting them now, close to motorways, close to logistics hubs, where we can get some bundling and get a few first movers, give them the opportunity to fuel. We're also trying to put, for air products, we're putting the locations close to our locations because we're converting our trucks. That's also an interesting challenge because we can't drive hydrogen with a fuel cell truck today. We need that regulation to catch up with that. But no, so we're being pretty strategic where we put the first ones. We're saying in 10 years' time, we think it'll be a lot more depot based, but we need to accompany that market take up first.
Okay, and Claudio, maybe also I have a question for you. What do you think? Will there be like local production on hydrogen refueling stations, or will it be more imported or by tube trailer that you can get the hydrogen on the site?
Production is a question mark, yes. Well, it depends. It probably depends also where you are. If you are in the south of Europe, you without the strategy to import green hydrogen. We're talking about green hydrogen, of course, from Northern Africa through pipelines. This is like maybe in the long time. If you are in the north, you have more wind, especially. I think there will be already green hydrogen available. The issue will be to distribute from the production to the fuel stations. For our small, I say we are a small company having some experience in production locally and distribution along a motorway. We see that it depends very much on the business case. We see in our region where the first users will have been actually historically bus companies, so local bus company, and they are moving now. So there are some examples in northern Italy where companies are taking locally in the depot also production, partially production, but at least a refueling station. So in this point of the time, also because of huge investments in the EU contributions, there are 2 lines. One is the buses companies, we say, which have a let's say high use need of hydrogen, and the other side is investing in the long time on the motorways without having actually the trucks coming. So I think this is will be the question marks in the next years, how they will survive from economic point of view.
Yeah.
That's why my questions to the colleague of Iveco were when trucks were coming on the market.
Yeah, and maybe for the hydrogen, so we are talking about gaseous hydrogen at a pressure of 350 bars, or do you believe that 700 bars will be like getting the standard also for trucks?
I think 700.
You believe in 700?
Definitely. I think we think hydrogen will really be the winner for the really long distance. We actually think Daimler's onto a good thing with the SLH2, with the liquid hydrogen on the tanks as well. So, you know, we think that's a really interesting one to get the long distances, and we're watching that interesting because we also have liquid sources, and we think liquid-based fuel stations will are the best or the most efficient for high capacity, large HRSs. So I think 350 will be a difficult sell versus the battery. I think the battery will win out on the short range.
Okay, and
Yes,
then
I agree. Yes.
Then we should install some more liquefiers in Europe to get all that hydrogen liquefied.
Working on it.
At 20 degrees Kelvin. I really like that process. Yeah. Okay. Do you want to add something, Claudio?
No, I agree. 700 is already, they're already testing these trucks for having long range. You need a high pressure. Yes.
And then also with like the cooling as it's done now.
350 will be focused for buses, I think.
Okay, perfect. Then maybe something about the impact on the mission planning of getting the infrastructure ready. We are in a transition phase, and in the transition phase there will be the risk like that the infrastructure needs to be available at a certain time slot, because otherwise your mission planning goes wrong. I don't know, do you see some opportunities or maybe solutions that can be optimized during the first years?
This is actually the charging slots, right? So
the charging slots that I know, like hydrogen refueling stations, they are like, you can come 3 trucks per hour, and then I need to do this, and then they are quite, they are designed.
That's today's,
That's
I think
today's.
the new future ones, it will be back-to-back fueling. So the stations we're building and designing are built for the back-to-back fuelings, where there won't be the slot issues of today.
So if you now look
away.
to a diesel station, they refuel like 90 diesel trucks at least per day with like 600 kilograms of fuel. So you think that stations for 90, so that you don't need to serve a spot, and that the refueling time will be fast enough that the driver don't lose time at your station.
If you look at the 6 tons a day, 6,000 kilos a day, that you can do a good 70, 80 trucks a day, right? And our new compressors can do that. They can do
Super.
And actually do the 6 tons a day.
I'm happy to hear that.
We're not booking slots.
Okay.
I think it's more of a challenge on the charging,
for the charging
which is
infrastructure.
longer slots.
For the charging infrastructure, we've discussed this with logistics company in ZEFES and also in the German HOLA project. And I think it's very clear that during the planning of routes, when the dispatcher plans where the truck will go, automatically a reservation for suitable spots, for suitable charging points will have to be found and made and confirmed. And using telemetry, it will have to be shifted if there are delays, so that both the slot is freed for those that are standing in the traffic jam before the one and who need their shift, and the next one will need to take one. That will keep the infrastructure costs down, and that will give, from the first use on the security to the logistics companies, there will be a charger, it will be available to be used, and it will not need to extend the driver's break. And this will be planned in from the beginning, so this will not be something that has to be added as an afterthought.
Yeah.
And something that is very important is that inside the charger we have several converters, and then you can play with them to charge at different, let's say, currents that the battery is asking from the charger. And really, there is a lot of flexibility in the charger. It's not only, you have the number of dispenser, of course, but you can play with the dispenser and the power that you are sending to each of the dispensers. And actually, the truck will load not like a flat line. It will let's say, charge and ask current, and actually the voltage that you need to deliver will be different. The thing is that the current that they will ask is different. Then with power electronics, you will be able to as well adapt to each of the currents that you are asking for. Then really in one charger, you can optimize a lot the power that is available.
So what I hear now is that the charger, even if it's designed to maybe that it could be like 300 kilowatt to maybe 1 megawatt.
Exactly, you have 1 megawatt, you can charge, if you have the dispenser, several at the same time, at the lower, let's say, current.
Again, some flexibility that that will be needed to get everything going, because maybe there will be an app. I really believe also in digitalization that there will be an app, and then the driver can say, "Oh, it only needs to be charged in an hour. I will now have really."
And as Kai was saying, the digitalization, information, and communication with the charger will be key there to plan the charging time and power.
Yeah. Okay. Then maybe. One last question. Can you maybe disclose a little bit on the price range of hydrogen stations or multi-charge stations, and what would be the price of the hydrogen at a dispenser or the electricity out of the charger? Could you already say something about that, or is that too far in the future?
I will start and I will give the word to Kai, and he will say, no. The price. I think we need to be very aware about when we talk about prices, about what we are talking. Are we talking about the charger alone, the charger, the dispenser, the charger dispenser digitalization, the charger dispenser digitalization and service? I mean, I don't think it's useful to talk about price without understanding what we are talking about. Another thing about prices that I think is very important is that even if we produce a charger, we don't decide the price. The price is something that we decide, the one selling the charger and the one buying the charger. And here again, the business case is super important, and it's the one who will decide. What is clear, and I have target prices because I'm the R&D manager for the charger. I have the target prices from the industry, and they are reachable. But I will, of course, not disclose that because it's maybe Kai has others. But the key here is to know about the added value. I will use a case of hydrogen. If you buy today, gray hydrogen is $1.5 per kilogram. I don't think green will cost that. But maybe the company is ready to buy a little bit more expensive hydrogen because it's already green, maybe $2.5 per kilogram. Here we have the same case. Then I think it's about added value at the end of the day.
I can also add that I also don't have the permission to give our target price for the megawatt charging system. Sorry. But 350 kilowatt, the charger would be 100 to 150K list price with added cost for grid connection, potential for rebates, depending on when you order, which can be enormous. Contact us for quotes. We will work out together with you how much it will cost. I could also try to go into business cases, but I'm biased, so I can point towards academics who have done the calculations for us, and they find cost parity depending on use case between today and 2023 for battery electric trucks. Today, especially in Germany, with an 80% subsidy on added cost of new truck and on charging infrastructure, including in some cases transformers and grid connection. There they see already cost benefit for electric trucks in some use cases today. They can be found from Transport and Environment, from EFOI. A certain Fraunhofer has provided something in this regard. So this, again, depending on use case, you can look at and see from an independent source. This will also, of course, help you very much for being an early mover. And of course, if you want to electrify a truck, use the one that does the most mileage. Your invest goes up tremendously, but your fuel cost effectively today, especially if you do mostly depot charging, will go down. And the more trucks you have, the more you can combine fewer chargers with more trucks. Then again, that infrastructure cost goes down. And if you add a little bit of intelligent route planning, you also need very few chargers per truck because you don't all have to charge at the same time. Again, we can give more information, direct contact on how exactly that would be in your use case.
And then maybe something on the hydrogen that you want to share with this public.
Yeah, well, hydrogen is a bit more complicated maybe. On one side is production, so for sure, all the investment and new products, electrolyzers and so on, which are coming on the market, is for sure decrease in cost themselves. There's on the other side this expected increase in component of green electricity, green energy. So there are projections that say that in the midterms, 1 kilo hydrogen can cost about €2 per kilo. So also because of that. On the other side, I can say something similar to what Mario was saying, and the price is made by the customer. We see that the interest also from the logistic colleagues, they are ready to pay more to pay more also for a truck, but also for having a green solution because they believe in it. But it's not a value, ideal value. There's also some at this point of time conditions also on obligations, rules, regulations to go into this market. So I think this is also to be taken in consideration. It's not only an economic addition, say, there's also an obligation to do something towards sustainability, and this is also would be driven by that. And the other side, fossil fuels will be probably be charged more. So in the balance of this in the midterms will say what is going on.
Yeah, I agree. We'd love green hydrogen to be at a parity with diesel. It isn't going to happen on its own, right? So, there's a premium that we have to pay for the cost of generating that green hydrogen. There's an excellent reason why, industry has been making hydrogen and using it for years as grey hydrogen with steam methane reforming, because that was the lowest cost of producing it. And the reality was the colour wasn't that important. The lowest cost of production was electrolyzer hydrogen is more expensive. And yes, we'll get some efficiencies, but we're never going to get down to the levels of the grey hydrogen, in my opinion. The only way we can really do that is really help the end users and maybe help with some subsidies. At the moment, there's subsidies on the capex, the capital to put the fueling infrastructure in place, but there's no support for the end user in the actual fuel. And we think that's the gap. How do we help bridge that gap? Well, we would appreciate there some support for the end users to really get that market uptake. We'll try and bring some efficiencies over the years. That's going to take a long time. The capacities of electrolysis we're putting on the ground now aren't suddenly going to get cheaper. It's going to take a long time.
Okay, that was my last question because we're out of time. Is there a question from the audience that for the panelists? No, so I think what we can say is that the infrastructure will be ready by 2024 for the first trucks, and then we will work together on getting it ready to 2030. And if you want to install it yourself, I think we have here a nice panel that you can ask them to do it for you and work together on a nice project. Thank you very much.
Thank you.
Yeah.
Thank you.